Hi guys, welcome to Jaman's MATLAB coding. In the previous clip, scalar and vector codes addressed. In this clip, we are going to illustrate these two codes execution on numeric. Scalar code assists in element by element computing. Let us consider screen shown matrix A, which is 224755. Now, if we use A dot hat 2, then every element in A going to be squared. For instance, first column, second row intersecting element 7, square of which 49. Now go to MATLAB command prompt, enter the rectangular matrix A as mentioned in clip 1. Now at this point, at the end of the statement, there is a semicolon. Now semicolon indicates suppression of output. So you're not gonna see anything. MATLAB will be ready at the command prompt. So at the prompt, you type a dot head 2 and you will see the result immediately. Dot forward slash easily can conduct reciprocal on all elements of a matrix. For instance, last slide mentioned matrix A will be calculated as 1 by 2, 1 by 2, 1 by 4, 1 by 7, 1 by 5, 1 by 5. So go to MATLAB command prompt, type 1 dot forward slash A, press enter, and you will see the result. Now in the execution, you find that the result is returned as a 4 decimal number, which is the default setting of MATLAB. You can change the format any other if you like. For instance, 1 by 7, which is 0.1429, and that is what you see on the screen. In order to conduct dot asterisk scalar operation, we need two identical size matrices, and if the sizes are not same, we will receive error message from MATLAB. On screen, you see there are two matrices A and B. Is of size 2 by 3. Now, coordinate 1 1 of matrix A has 2, coordinate 1 1 of matrix B has 3. So their product is 6, and continuing this way, we see the product matrix as 6, 8, 16, 0, 35, 15. So now go to MATLAB command prompt, enter matrix A, then enter matrix B. At this point, the two MATLAB statements are separated by a semicolon. This is MATLAB syntax. You can write them in one line, you can write them in two different lines. It is up to you. So then call a dot star b, press enter, you will see the result. Once again, this operation is possible if both matrices are identical in size, otherwise not. With ongoing A and B, now we are going to show A dot forward slash B operation. Here, like positional elements division, for instance 2 by 3, 2 by 4, 4 by 4, and so on. So to see this, you go to MATLAB command prompt, enter matrix A, enter matrix B like we did before, then execute A dot forward slash B at the command prompt of MATLAB, and MATLAB will give you the result in decimal form. The first division, which is 2 by 3 and which is also equals to 0.6667, and that is what you see in the return. At this point, 7 divided by 0 is infinity. So MATLAB returns that one as INF. Once again, this kind of element by element division possible when A and B exactly identical in size, and which is here 2 by 3. To see the implementation of vector codes for multiplication, we have to make sure that matrix algebra rule is maintained. For example, A can be any matrix size m times n, B can be any matrix size n times b, then vector product A asterisk B will be of matrix size m times b. Note that A second dimension is n, B first dimension is n. So that means number of columns of A must be equal to number of rows of B. Only then A asterisk B can be contacted, otherwise not. In order to implement vector multiplication, let us consider matrix A, which is of size 2 by 3, and matrix B, which is of size 3 by 2. So they are matrix product or vector product, not of course not element by element. It will be 36, 36, 67, 54. And the first element 36, I mean coordinate 1 element 36, how it comes, that is shown in expanded form, like 2 multiplied 1 plus 2 multiplied 7 plus 4 multiplied 5, this way. So go to MATLAB command prompt, enter matrix A, enter matrix B, then call A star B, press enter, and you will see the vector multiplied result right away. The other vector product, A forward slash B, only possible if both A and B are of a square size, like 2 by 2, 3 by 3, 4 by 4, etc. Again, A hat 2 is also possible if A is of a square size. And you see, there is no dot. This is completely matrix algebra based. If you need further help, you may try with the screenshot 2 texts. That's it for today. Thank you for showing up. I will look forward to having you in the next clip.